All right, hi everybody. What we're going to do today, I want to talk a little bit about inverses and not just explain how to find an inverse, but kind of explain what an inverse is. So if you're looking at this page from section 3 of your notes packet, okay, find the inverse of each function. This is a linear function. This is a cubic function. Okay, let's just talk about what an inverse is. If you have any function, something like, we'll call it f of x equals 5x minus 3. Okay, so that's simply a linear function. Just to focus. Okay, which is just y equals 5x minus 3. What we're doing when we find an inverse function, first of all, we can graph this. Y-intercept is negative 3. This is in the form of y equals m. That's your slope. X plus b. B is your y-intercept. Okay. Slope is 5. Up 5, 1, 2, 3, 4, 5 over 1. Slope is 5, which is the same as 5 over 1. Rise over run, so up 5 over 1. So we've got this point here. This would be the point 0, comma, negative 5. 0, comma, negative 3, sorry. And this is the point 1, comma, 2. Let's do one more point. Up 5, 1, 2, 3, 4, 5 over 1, which gets us to, go up 5 from here, 2, up 5 would be 7, so 2 comma 7, okay, and there's your line. If you were to make a table of values, we'll just put these three values in here, 0 comma negative 3, 1 comma 2, 2 comma 7. So a function, you put in an input and it spits out the output. For instance, if we look at this point, f of 1, that's our input, it should spit out a 2. Okay, so plugging in 1 for x, we plug in a 1 for x here, 5 times 1 minus 3. Oops, and we do in fact get 5 times 1 is 5, minus 3, 5 minus 3, and we get 2. Okay, so when 1 is the input, 2 is the output. That gives us the ordered pair 1 comma 2. Okay, now when we find an inverse function, what an inverse function is, it's a different function. It's another function that's related to this function. But instead of these being your inputs and these being your outputs, it reverses them. Okay, so that in the new function, these are the inputs. You start with the output, and what it spits out is the input. Okay, so in the new function, if we plugged in a 2, it should spit out a 1. If we plugged in a 7, it should spit out a 2. Okay, so here's 3 steps to find an inverse. Okay, so we're going to take, you'll see a little more of this. Okay, we're going to take step 1. You're going to replace f of x with y. Okay, and I'm going to make an example over here. We're going to look at this one. So this was our function, f of x equals 5x minus 3. First step, all I'm doing, this f of x, that just means your y value. It's your output. X is your input, your output is f of x or y. They mean the same thing, so we're just going to replace it. Y equals 5x minus 3. Step 2, we're going to swap x and y. This step is crucial because basically what we're doing, we want to switch the input with the output. So in the equation, we have to, the y becomes an x, and the x becomes a y. Nothing else changes. Notice that 5 didn't change. That minus 3 didn't change. The equals didn't change. Nothing changed. We didn't really do any math there. We didn't do much with numbers. We just replaced. The y became an x, the x became a y. And then the last step, you're going to solve for your new y. Okay, here's our new y. We call it a new y because it used to be an x in the original function. Okay, now we want to get this y by itself. So to get this y by itself, okay, we want to get this thing by itself right here. which means we have to get rid of the 5 and get rid of the minus 3. Easiest way to get rid of a negative 3 that's just being subtracted, the opposite of subtracting is adding. We're going to add 3 to both sides. So this becomes x plus 3 equals 5y. And then the minus 3 plus 3 is 0, so we can get rid of that. Okay. Last step, get the y by itself, divide both sides by 5. 5 divided by 5 is 1. That's just 1y. So here's our equation. Our inverse equation is y equals x plus 3 over 5. If we want to write that in inverse notation, it looks like this. It looks like f of x, but we put a little minus 1 up there. F inverse of x equals x plus 3 over 5. Okay, and that's your answer. That's your inverse function. So now let's test it out. Let's take these values. Now, if 2 was our input, it should spit out a 1. So let's do f inverse of 2 equals, you replace the x with the 2 plus 3 over 5. Plugged in the 2 there for x, 5 over 5, and we get 1. So when our input is 2, our output is 1. It just switched these. It's the inverse function because it does the inverse of what the original function does. Let's try this one. If we plug 7 in, it should spit out a 2. F inverse of 7 equals 7 plus 3. We're replacing 7 with x. So 7 plus 3 over 5 equals 10 over 5, which is 2, which is exactly what we were supposed to get. When our input is 7, our output should be 2. It just flipped the x and the y. Okay, so let's try a few of these. We're going to do these two problems at the top. Okay, f of x equals 3x minus 9. Remember our 3 steps here. We're going to replace f of x with y, switch x and y, and then solve for the new y. So step 1, we just rewrite the f of x as a y. Step 2, you swap x and y. The y becomes an x becomes a y. And now we're going to step 3, solve for the new y. So that y we have to solve for, get rid of the negative 9, add 9 to both sides. X plus 9, you cannot combine the x and the 9, they're not like terms, so we have to keep them separate. Equals 3y, and then their negative 9 plus 9 is 0. Let's bring this over here. I'm going to put the 3y on the left side. Okay, we want to get the y by itself. The y is being multiplied by a 3, so to unmultiply, we divide. You get y equals, the 3's cancel, x plus 9 over 3. And that is your inverse function. F inverse of x equals x plus 9 over 3. Okay, so we just followed these 3 steps. Now, when you do the delta math, sometimes it's multiple choice, and sometimes you won't see this exact answer. Sometimes they have a different form. Sometimes they simplify it differently. If you have a sum of 2 terms divided by 3, you can also take each term and divide by 3. You can call that x divided by 3 plus 9 divided by 3. So divide the x by 3, divide the 9 by 3, and then that's going to give you x over 3 plus 9 divided by 3 is 3. Okay? So you might have the answer f inverse of x is equal to x over 3 plus 3. Okay? Both of these are correct, but when you're doing multiple choice, if this isn't there, you might have to kind of simplify and see what else is equivalent. Okay? Let's look at the next one. This one's a little trickier just because the algebra is a little harder, but it's the same original 3 steps. I'm going to start up here with step 1. You're going to rewrite the f of x as y. Remember our steps right here. Replace f of x with y. In this case, it's g of x, but the same thing applies. So y equals x cubed plus 1. Second step, swap x and y. So everywhere you see a y, it becomes an x. Everywhere you see an x, it becomes a y. Okay. Now we're going to solve for the new y. Solve for the new y, step 3. We have to get this y by itself, okay? So let's just move this over here. X equals y cubed plus 1. The easiest thing to do is get rid of the 1 first. Subtract 1 from both sides. That goes away. You get y cubed equals x minus 1. Okay. Now, this is tricky. We've got y cubed. How do you uncube something? Well, let's think about how did we unsquare something. If I had x squared equal to 25, you had to unsquare it, and the opposite or the inverse of squaring something is you'd take the square root. If something is squared and you take a square root, those cancel and you simply get your x. Then you get plus or minus the square root of your 25, which is 5. Okay. So how do you uncube something? If I've got x cubed equal to 8, well, you uncube something by cube rooting it. Okay. So x cubed equal to 8, you take the cube root of both sides. It looks like a square root, but you've got a little cube in there to show that you need 3 of something to be able to uncube something. You're saying, what number multiplied by itself 3 times gives me that number? This cube root and x cubed, those cancel, and you get x equals the cube root of 8. Now, when you take the cube root of 8, just like when you took the cube root of the square root of 25, a square root, you're looking for 2 things multiplied together to give you that number. 5 times 5. So the square root undoes the square, and you get 5. Cube root, you need something multiplied by itself 3 times. Okay, so that's the cube root. The nice thing about this is 8 breaks down into 4 times 2. Then 4 breaks down into 2 times 2. And then bring down the other 2. We do have something multiplied by itself 3 times. And so therefore, that becomes a 2. Okay, so x just equals 2. Just if you want to look at this, remember our perfect squares. If you square 6, you get 36. If you square root 36, you're back to 6. Okay. If you cube 2, 2 cubed, 2 times 2 times 2, that gives you 8. If you cube root 8, you're back to the 2. Okay. 5 cubed is 125. If you cube root 125, you'll get 5. So the cube root of 125, we're saying what multiplied by itself 3 times gives you 125? Well, that number is 5. Okay. Cube root of 216. Well, 6, oh, that should be cubed. 6 cubed gives you 216. That's 6 times 6 times 6 gives you 216. Well, cube root of 216 is like what number multiplied by itself, and the multiplied by itself gives you 216, and that number is 6. So cubing goes this way, cube rooting goes this way. Okay, so what that means, and for our purposes, we don't even have to know all that. I just want you to understand what it means to cube root. But we have y cubed, we have to uncube that, so we're going to take a cube root. Then we cube root the other side also. Okay, cube root of y cubed, well, those undo each other, and we simply get y, which was our goal. We want to get y by itself. Okay, and then we get the cube root of x minus 1. Okay, so in function notation, you can rewrite the y as f inverse of x, and that's equal to the cube root of x minus 1. Okay, I hope that's helpful, and that is all for now.